Okay, so this is the presentation for my Module 3 Ensemble Learning Methods final. I used it to inform a move. This is going to be regarding weather patterns, predictions. I threw in a time series at the end too, just kind of for fun. So,
Okay.
This here is the table of context for the presentation here. We'll kind of just be going over the overall process. There's more details, I would say, on the blog, and then in the appendix also there will be a link to the main repo where there is more technical, it's the whole repository. So, all right. I thought it was interesting to do a data set regarding weather. It seems like an obvious choice if we're trying to predict classifications. I think it's also kind of interesting right now. I was just reading about how a lot of software out there will try to sell you government data and just repackage it as a different weather software. So it's kind of interesting to me in that sense that this is all public and people are finding ways to use it for their own end. So obviously it's relevant data, I think. And also recently in the news, we just started finding out that water vapor vibrates at the same frequency as 5G networks. That kind of throws a wrench in the whole weather predicting game for the world. So it seems relevant in that sense too. People are going to be thinking about how can they overcome that challenge. So this is kind of the best quick overview I could think of for the data. I have the last 2 years of weather data for Burlington, Vermont, trying to figure out if I can get a model to predict what the weather looks like. So we have the legend here is the different classifications that we thought of for the labels. This is what the algorithm is trying to predict. And two of the most important features we'll kind of use as a example throughout the presentation is temperature and pressure. They turned out to be really important and they're just good numbers to watch. Use the Dark Sky API. Actually, this is part of the agreement. They give you this information for free. They want you to mention that you used it in your final project. So even though this is educational, this seems like the right thing to do for me. The first step, once I got the data from Dark Sky, was to manipulate it in a way that it gives us as much information as possible and removes all the information we don't need. Yeah, about that. Feature importance, we then kind of use the final features, and it's good to check at this point to see and make sure it's drawing on all cylinders, I guess you could say. This kind of tells us what is informing the final decision almost at a percentage rate, although it's not quite that simple. And these are all the features I ended up using. So these last ones over here, we found that pressure and temperature really relevant. So we created a few more features to track the change in those, and they pay off a little bit, it sure looks like. So, first step in getting to ensemble methods is first making sure that this data is going to work and it's going to make sense to categorizing supervised learning algorithm. Decision trees are pretty basic. We can find out if they work from here. They're also pretty intuitive. This right here is a quick example of credit card approval. So you have each, let's say, row of decisions is almost like another feature. And then yes or no, simple choice on whether they meet the criteria, fits it into the right box. Either the box is represented another way. As we get into some of the more difficult ensemble methods, support vector machines, it's into the nitty-gritty and kind of allows you to tweak the area between the 2 points. Now, before there was boxes, the boxes had lines. This is a matter of fine-tuning those lines to catch new data points or new dots. An extension of another Ensemble method that we used was an extension of the decision tree. Think of lots of decision trees, and that gave us our best results. This was the final number we went with. So what we want to look at here is the validation accuracy. The training accuracy is how well it predicts its own data. Validation accuracy would be new data, new measurements coming in, new days on the calendar. What will the weather look like? That's 67%. Pretty happy with that. A random guess with this many classifications put me at 14%. Now that is just one way to measure the strength of a prediction. There's other measurements, but for now I think accuracy makes sense. And then just for fun, this would be the temperature readings over the last 2 years, and there at the very edge would be what we can kind of assume the readings will be for the next month. More trends on that. If I were to go forward with this, I would focus on upsampling the precipitation events. They represent a small percentage of the number of results we have for the outcome, the labels. Collecting data from surrounding stations, because weather is not a closed system. So obviously getting the area around would let you know when weather is coming in, pretty useful feature. And using the entire data set to predict future outlooks. Right now, they just predict possibly the current day. It'd be interesting to kind of change the data set so that we can be more informative with our results. Okay, that is all I have. Thank you for your time. Link to other stuff if you want.